Hello, everyone, and dear authors and invited guests, welcome to this technical session 4D. I am Dimahi Patel, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 10th Congress on Information and Communication Technology, London, United Kingdom. The 10th edition of this international conference is being organized in hybrid mode. The physical event was held yesterday in London, and the virtual event is being held through Zoom from 19 to 21st February 2025. I hope you will enjoy this knowledgeable and interactive sessions throughout the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for the presentations and 3 minutes for question and answers. On 10 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we start the session, I'd like to introduce you all to the chair of this session. We have with us Mr. Ricky Sun. Mr. Ricky Sun is currently a director of the Asian Art Committee of the Harvard Art Museum. He is a senior entrepreneur, world-class high-performance computing and storage system, and big data expert, having more than 20 years of experience in Silicon Valley and Beijing startups and multinational companies. He has authored 6 popular technology bestsellers and holds more than 50 US and Chinese patents. We welcome Sir to the session, and I would request you to share a few opening remarks to the presentees that we have today.
Well, thank you for the introduction. Well, happy to be here. I understand we are all virtual, so no one is physical in London, right?
Yes,
Okay,
sir.
that's perfect. That's perfect. I did spend some time looking over like all the abstract of the 6 papers. I do have I got myself prepared with questions, but not for every single paper because of the limiting information what I can see now. So maybe after I carefully listening to the presentations, I probably can bring up some interesting questions. So let's get started.
Yes, sure. So, thank you, sir. We also have with us Dr. Tanupriya Chaudhary as our chair for this session. Dr. Tanupriya Chaudhary has 10 years of experience in teaching as well as in research. Currently, he is working as a professor research at CSA Department and Associate Dean Research at Graphic Era Deemed to be University, Dehradun, India. His areas of interest include human computing, soft computing, cloud computing, data mining, and he is a lifetime member of IETA, member of IEEE, and member of IET, and other renowned technical societies. We welcome you, sir, and I would request you to share a few words to the presentees here. Yes, sir. Okay, so now we'll be starting with the presentations. First up, we have Devjani Mazumder. Ma'am, are you present here? Devjani? She will be presenting her paper on a probabilistic graphical model for concept identification from educational documents. Dibjani, if you're here, can you please share your screen and start with the presentation?
Dimay, I think Joshi is absent. You can go for the next present.
Okay, so for the next presenter, we have Eric to present his paper on DOS attack detection using a machine learning and multi-objective optimization approach in IoT networks. Eric, if you're
Yes,
present
hello.
here, can you present your screen?
Yes, hello. How are you?
Hello, hello. Please start with the presentation.
So can you see the presentation?
Yes, we can.
Okay. I will start. Hello. This is the presentation of the paper called DOS attack detection using a machine learning and multi-objective optimization approach in IoT networks. Yeah, this will be our agenda. Basically, we will go through a brief introduction, then up the problem, general goal, or proposal, the dataset used, proposed solution, solution design, and results. So yeah, we'll go through that. So a basic introduction. Basically, what is an IoT network? An IoT network is a network that has IoT devices, gateways, and apps. And to have a little of a definition on IoT devices, basically, the National Institute of Standards define an IoT device as a devices that have at least one transducer, sensor, or actuator for interacting directly with the physical world, and at least one network interface, Ethernet, Wi-Fi, Bluetooth for interfacing with the digital world, basically. And these kind of networks are used in smart agriculture, healthcare, transportation and logistics, traffic monitoring, smart home, and other applications, basically. What is our problem? Basically, in what we are seeing is that we have an increasing amount of devices, of IoT devices on the web that is expected to be 41.1 billion on 2030. That is almost the double of the amount that we have in this moment. So having vulnerable devices on each of our networks is a serious problematic to take into account. So basically, our problem is that malicious individuals could appear to attack the IoT network. We will focus on this problem on DOS attacks. That basically the definition of it is the definition by Palo Alto is a denial of service DOS attacks is a malicious attempt to disrupt or shut down the normal functioning of a targeted server, service, or network by overwhelming it with a flood of illegitimate requests and trigger a crash, basically. So why is this important? Because, for example, a more complex kind of attack called DDoS attacks that happened on 2016 take down Netflix, Twitter, and GitHub for hours. So it's a pretty concerning topic. So our general goal is to propose a solution to identify when an IoT device is under DDoS attacks and then we need it to neutralize the threat, basically. So the goal, develop efficient models for traffic analysis and attack prediction. And in terms of performance, ensure high accuracy with minimal inference time. And in traffic analysis to predict attacks by analyzing network traffic. The dataset that we will use is basically the dataset called CCOT dataset of 2023 from the University of New Brunswick, which objective is to propose a novel and extensive IoT attack dataset to foster the development of security analytics applications in real IoT operations. Okay, so to start with the solution design, basically we need to talk about what we will refer as a subgroup. So a subgroup will be a combination of a model and a dimensionality reduction technique. For example, a group can be a random forest with PCA, a random forest with LSCA, and basically that will be subgroups. It's pretty important to get that. Yeah. So this is our methodology, and we will go through each of the steps by one. Our first step is to use a Bayesian search for high parameter optimization on each of the subgroups with 5-fold cross validation with 50 iterations. Basically, the output of this will be 50 models that are pretty much, or we think that they are optimized to search F1 in this case. Yeah, basically that. Then when we have each of the 50 models in each of the subsets, we will go to calculate the F1 score on the remaining 80% of the data. Why 80? Because we train off on 20% of the data because of the capacity that we have. So we didn't train on in 80% of the data, but 20. And then we will evaluate, once we have that metric, we will evaluate prediction times of some subsets that also the model has not seen. So basically, we will make four subsets of 500,000 rows to get the prediction time of that amount, and basically that. So in this moment, we will have the F1 score calculated in the 80% of the data that the model has not seen, and the inferences times of the average in the four subsets of 500,000 rows, basically. When we have all these metrics, we will calculate a linear regression between records and time, and then evaluate the stability, calculated metrics like R-score, MC, and slope. So what is the logic of this? Basically, the idea is to have a general sense of stability of the model. So basically, a model that that we can predict how much time it will take to predict a number of rows will have a lesser we have a less error when we do the regression. And basically, a better model will have a high R score, lower MC, and for terms of scalability, we will search for a lower slope. So this will be our five metrics to optimize. Then, when we have all these five metrics, we will optimize the metrics using SGA2. Basically, it's a genetic algorithm to get all the Pareto fronts. And this is basically it. And then when we have all the Pareto fronts, we will calculate something that is called pseudo weights. That in general, basically our ideal model will be composed of a vector of zeros, because that's the distance between the for example the R square and the best R square that we have in the subset. So yeah, and we will select the one that the vector that has a lower distance between the vector of zeros and the one that was calculated and for the model. And that's how we calculate that red one up there. And then the last phase will be to set the threshold. So basically, the general idea is to set a threshold to make the prediction. Usually, the models have the threshold in 3.5, but the idea with this is to use Bayesian optimization to search the best threshold to make the prediction. With all of that, what we get is something like this, where we have the best models among all the subgroups. For example, the PCA in the DNN model. Basically, it's the best model among them all in the subgroup. And for all of these of these models, we will calculate our final score to decide which model to use, dividing the F1 between the inference time. So getting that, we will select these two models. Basically, the first one is a random forest model, which F1 is basically perfect. The R square, that if you remember is basically calculated in the linear regression between the records and the time. That means that we have high predictability. Also, we can see that when we see the MC, and we have a lower score. And that model takes 0.4546 seconds to predict 500,000 rows, or 500,000 rows. And another model that is the XGBoost model, that it's also almost perfect, not as good as the random forest, with a lower predictability. Looking at the R square and the MC, a lower score compared to the random forest, but the time it takes to make the predictions is lower than the random forest. So it depends of the person that it's choosing. It depends on the business business problem and other stuff. But basically, those are the results, and that concludes the presentation. We'll answer questions.
It's
Yeah.
very nice presentation indeed. This said Professor Tanupriya Chaudhary. Mistakenly, I think uh, it has mentioned that I am working at Graphic Era. Right now, I am working at a professor at University of Petroleum and Energy Studies, Dehradun. Going ahead, in your presentation, you have mentioned only random forest and XGBoost. May I know only why these two models?
Yes, it was. We basically test with DNN singularity perceptron random forest and XGBoost with those four models. We also tried with another model, but it's not here because the inference times were awful. But if you can see in the area of the, for example, around the forest, we have the one that is the one with PCA have a final score of 2.188, and that's why we selected it. And for the XGBoost, you can see there is another one that is the one that has the score in three. So that's why we selected these three models.
Okay, it's fine and very good concept also, as they have also included some of the statistical methods like ANOVA as well. And is there anywhere you have used loss functions as well?
Mm, I haven't seen that, but yeah, I used basically.
Okay,
That's
these are pre-generated model, I think. But if you are going for some journal submission and all, please try to use the loss function so that how accurate your model is would be correctly identified. Thank you. Over to
okay.
the session chair, please. Thank you.
Thank you, sir. We'll see about
Yep.
this. Rekisa, do you have any question for the presentation?
No, I'm good. Thank you.
Thank you.
Okay, thank you so much, Eric, for your presentation. Now I would like to request Virod if he is present here. Virod, are you present? Okay, I would request Virod to present his study on dynamic handgun detection with YOLO V11 from images to real-time CCTV monitoring. Over to you, sir.
Yes, yes, yes.
You may switch off the other systems. Echo is coming. Only one system you can use. We are having some echo issues. Your voice is not coming
Okay,
properly.
okay, okay. Hello. Hello.
Sir, it is still echoing.
Hello. That's okay. Okay.
Please use only one system. You might have
Okay.
using multiple systems. Switch off the other systems and connect through only one system.
Okay. Okay. That's okay.
Ah, yes, now it is okay. You may start your presentation, please.
Hello. Hello. Good morning, ladies and gentlemen. Today we would like to present dynamic handgun detection with YOLO version 11 from image to real-time CCTV monitoring. Presenter, my name is Suchai Phumpuang, is studying in the Faculty of Engineering, majoring in Electrical Engineering, and studying in Phetchaburi Rajabhat University.
My name is Panawat Kunmi. I'm currently studying electrical engineering at Phetchaburi Rajabhat University.
Hello, my name is Pisit Paikap, currently studying electrical engineering at Phetchaburi Rajabhat University.
Good morning, ladies and gentlemen. My name is Nalongsak Warapok. I study at Phetchaburi Rajabhat University, Faculty of Engineering, Department of Electrical Engineering.
Agenda first, introduction, second, research methodology, third, implementation, fourth, result, fifth, conclusion. Introduction. On the October 3rd, 2023, a tragic shooting occurred at Siam Paragon Mall in Bangkok from Thailand. A 14-year-old boy carried out the attack, resulting in two deaths, a Chinese in tourist and a Myanmar employee and 5 injuries. Introduction security. Due to the current situation of increasing violence in society, safety has become a major concern. Since existing surveillance cameras are not advised and to accurately detect threats, we have developed a camera capable of detecting firearms. This is the foundation of our project. Table 1, a comprehensive study of YOLO version 7 to YOLO version 11 in handgun detection and surveillance. After verifying with YOLO version 11, we found that it achieved 96% accuracy. Therefore, we implemented this model and recorded to experimental result in a table based on the collected statistical data. Introduction gun detection by YOLO 11 so that we used YOLO version 11 in this study.
Second, methodology, research design, data collection, model development, results. 2.1 Research design. We have a data set, total images, 2014 images. In the 10 sets, 80% use 1,615 images. Valid set 15%. Use 300 images. Test set 5%. Use 99 images. 2.2 Data collection to train and test the Euro V11 model. A dataset of images containing firearms is required. The dataset will consist of various types of firearms, such as handguns, rifles, and shotguns, taken from public repositories or created specifically for this research. This picture shows example images without bounding box, and this picture shows example images with bounding box. Third, implementation. YOLO V11 is YOLO V11 is a P10 model, primarily used for object detection, but it can also be adapted for face recognition or other tasks by incorporating CT-K2 block and C2 PSA block. The model can be enhanced to improve its ability to compare and distinguish between different objects or faces more effectively.
For result, the confusion matrix serves as a basis for delivering several performance metrics such as precision, recall, and F1 score. The precision confidence curve visually illustrates the correlation between accuracy and confidence levels in the YOLO version 11 in handgun detection. Recall confidence curve depicts how recall varies with changes to the confidence threshold. Lowering the threshold increases the number of predictions accepted as valid. The precision recall curve serves as an insightful tool for evaluating the performance and effectiveness of the YOLO version 11 in handgun detection. The F1 confidence curve illustrates how the F1 score varies across different confidence thresholds. This is the result of video-based prediction. This is the result of real-time prediction. This is the result of real-time prediction with multiple persons in the background.
Fifth, fifth conclusion. This study demonstrates the effectiveness of Euro V11 in handgun detection across diverse scenarios, including static image, video stream, and real-time CCTV monitoring, leveraging its advanced transformer-based architecture and adaptive scene understanding. Euro V11 achieved high accuracy with minimal false positives, ensuring reliable detection even under challenging conditions. The results confirm that Euro V11 outperforms its predecessor in both precision and speed, making it a robust solution for public safety application. By successfully implementing the model across multiple modalities, this research highlights YOLO V11's potential for integration into real-world surveillance system to enhance thief detection and prevention. Thank you. Do you have any question?
Can you please discuss your dataset?
Hit share ตรงไหนวะ
พูดอะไรเนี่ย
นะครับกดหยุดแชร์ตรงนั้น โอเคพูดเลย Do you have any question?
Can you please share your dataset characteristics?
จาน data set metric data set
And if not, it's fine. Thank you. No questions more.
ว่าเป็นพูดไม่ตอบ
Try again.
Sorry, repeat again. Please, please.
Can you please showcase the dataset description, attributes description, and how you have taken the data in your system, what kind of attributes value you have taken?
Oh,
And if
and
not,
from
it's fine.
global whole.
Comment.
It the picture
แชร์ไมค์
ใช่ไหม
แค่ไม่ใช่ไหม
wait
ก็เดี๋ยวว่า
ใช่
รู้แต่
อืม
Ricky sir, do you have any question for the presentation?
Well, actually, I do have a question, but this is kind of a rhetoric because I think on the last slide, the presenter indicated there's a potential to integrate this YOLO 11 based system with a real world surveillance system. So I understand YOLO framework is pretty friendly to integrate with edge processing, meaning, assuming you're hardened the solution to a surveillance camera. And the surveillance camera can potentially process like the handgun recognition locally. Is my understanding right?
sorry could you please again repeat again please because I just cannot hearing clearly for your sound just
Oh, okay. No problem. So this is actually I'm actually asking what, like, are you guys targeting integrating or harden your solution to support edge processing? I mean, like, basically harden this YOLO-based framework or system to be self-contained functional over a like a surveillance camera. It doesn't really require like a central server to process it. I mean, the surveillance camera itself will be able to process it.
Mm. But this is implement in the standalone, just only the one for the uh, webcam. So in the future, in the next phase, we would like to research in the full system, maybe have more than one camera.
Got
So
it.
it is still implement in the server look like in the full system. But in the next phase, we will implement in the full system with the server that we can record for the all the camera from the CC1, CC2, TV2. We can look at in the mobile also. But in this project, we concern only for the in the standalone, and we would like to make sure for the YOLO 11 can do it. After that, in the future, nearly I would like to research in the full system with more than cameras, and we will have the server in the centralized, and we can use the mobile uh, to look at the real time. Okay.
Yeah, got it. Well, good to see you again, Dr. Wyrot. Thank you.
Mhm. Okay. Thank you much.
Mhm.
Okay, sir, do you have any more questions?
No, ma'am, no questions.
Okay. Okay, thank you for your presentation, team. Now I would like to call Pei Yi Hao for his paper on integration of classification, regression, and ranking tasks into a novel multitask SVM for stock market prediction. Pei Yi Hao, are you here? I repeat, author Pei Yi Hao, are you present here?
Dimai, please move for the next presentation.
Okay, next up we have Paula presenting her study on modern approaches to learning assessment in online education, bridging traditional and innovative practices. Paula, can you please share your screen?
Hello, good morning. Let me just reorganize this and share only the PowerPoint, if it's okay. Okay, I believe you can see my screen now.
Yes, sir, your screen is visible.
Okay, so is it okay to start?
Yes, sir, you may start, please.
Okay, so thank you very much for the opportunity to be here and to present to you. I'm afraid what we are discussing with you is very much different from the other papers in the session, but I hope that somehow it is still relevant for those of you who are teaching or who are involved in the education world, because we are not talking about any machine learning techniques, but talking about uh, techniques to assess the learning of our students in a world of education where online tools are more and more prevalent. So my name is Nuno Escudeiro. I'm here on behalf of Paula Escudeiro, so I'm one of the authors of the paper. Paula cannot be here with us, so she asked me to present on her behalf. We are all from the Polytechnic of Porto, from the Department of Informatics, and we are involved in internationalization of education for many years. I would like, first of all, to start saying that, okay, education with these last years with the COVID, we have suddenly had to move to online teaching. And in this session, we are going to focus on a particular aspect, which is the assessment practices in online education. So we'd like to discuss with you and present with you some assessment strategies that are mixing the traditional assessment that we are used to with new techniques that are available when you are teaching online, with all the problems that this raises and with all the opportunities that this raises. These strategies that we would like to discuss with you are emphasizing learners' engagement, flexibility, and collaborative approaches in these virtual and blended learning environments. We hope that by the end of the session, the people attending will have some hints or some better understanding, let's say, of these aspects. In traditional face-to-face learning, so training or assessment is very much focused on summative measures, final exams, written papers, quizzes, this type of tools. When we go to online education, we need new assessment strategies to promote two very important aspects of assessment. On one way, engagement of the students, and on the other way, to assure the academic integrity, to assure that we are assessing, in fact, what we want to assess from our students and not some other impacts that they might be subject to, both because they are not present in person in these assessment moments. And this is a critical point here. So we are seeing that during these days there is a shift towards continuous assessment because of all of this. So we are moving more and more to continuous assessment, which was already practiced for ages, let's say, but there is a tendency to go more on this direction than on those assessment moments, very specific 1 or 2 moments of assessment during the courses. And this is allowing the learners to show not only their art skills, but also their soft skills in a much more flexive and reflective manner. And reflection here on the progress of learning is key to understand and to develop the competencies and the knowledge that we want to develop in our students. There are many new ways for teaching and for learning. Some are here already for ages, some are here for ages, but not really being explored for the benefit of our students. We may talk about the MOOCs, Massive Open Online Courses, that I'm sure you all know, that in a certain way leads the way to create flexible learning environments. But there are many new approaches that are coming, mainly since 2020, because of this sudden change to online due to the COVID. We have a very promising approach, the COIL courses. COIL stands for Collaborative Online International Learning, and it's a way of promoting internationalization through online classes where a given subject is taught by a group of teachers that are from different universities, each one focusing on a certain module or some other organization. And we have also students working together from different universities. So it's a really cooperation, international cooperation, using these blended or hybrid environments where we have some students in face, other students online. There are other approaches that we are developing significantly in my department at the Polytechnic of Porto, promoting blended mobility academic activities. Blended mobility in the sense that we are blending virtual participation with face-to-face participation. We have in particular a project-based course where the students are organized in international teams or with multidisciplinary competencies involved to solve a challenge for a company. And these students are meeting during 1 week at the kickoff of the course. In fact, this week is the week when we are running the kickoff meeting for this year. The students are here in Porto for all the week to know the companies, to know in more detail the challenge they have to face, to organize themselves as a team, and then they go to their home universities and they work during all the semester using online tools to communicate and to develop their project as a team with a common goal. In the end, they have another meeting all together. This year it will be in Trier in Germany, where the students will present their results and be assessed by that. So there are many new approaches that are coming by and that are in fact forcing us to find new ways of assessing the students, because in all these new learning environments we find opportunities for internationalization that were not there before, for multidisciplinarity cooperation, but of course these require new strategies for assessment related to group-based learning, to reflective practices, and we'd like to use on this. We have mainly these two ways of organizing our academic activities, with synchronous or asynchronous activities, and the assessment can also be brought into the scene either synchronously or asynchronously. And of course, these have different problems and different challenges. So asynchronous assessment gives the students flexibility and gives the students the chance to do some research and some more deep thoughts about what they are being assessed for. When we go on synchronous assessment, then we have like live chats, video conferences. This has the advantage of giving the students real-time communication. So if a student has a question, has a doubt, it will be immediately fixed by the teacher who is with him or by the peers that are with him. So these are two different challenges that pose different scenarios, that pose different challenges to the assessment tasks. I would like to briefly go with you with the pros and cons, advantages and disadvantages of these both scenarios. In a synchronous assessment, so when we ask the students to do some homework so that they can show what they have learned, this has positive aspects, mainly related to the flexibility, because the students can work on their own pace. We have no limitations. If we have an international class, we have no limitations with regards to the time zones of each one of our students. It is not causing that much stress to the students because they have more time to think and to research and to work around what they have to do. And it accommodates different learning styles because of this fact that the students are more free to do the tasks they have to do on their own um, according to their own experience and on what they are used to do. And of course, it is more accessible for the students. The negative points, I would say, is that it's harder to monitor and to assure academic integrity, and the fact that the students may somehow not get immediate responses to any questions they might have with regards to the assessment. Lack of engagement is also a critical issue because the students are on their own with a deadline, of course, but they are on their own and they may feel isolated and or start procrastinating and then having to do everything in the last minute. So this requires a lot of discipline from our students, which again, it's positive because it's a way to promote their soft skills in regards to committing to deadlines and these type of things. If we go to synchronous assessment, here, then we can also see positive and less positive or negative sides. So as the pros of synchronous assessment in comparison to asynchronous assessment, I would like to highlight the immediate feedback. So the teachers can immediately clarify any questions of the students. The fact that it's easier to monitor and to make sure that what the students are letting us know is on their own creation. It's more encouraging for the students, more motivating because they are there with us, and it's close to what we traditionally do, so it's easier to implement and does not cause any challenges that we are not used already from the past. The negative points, it requires technical issues that or technical conditions that might not be there. We might have challenges with different time zones from our students. And of course, the opposite of the asynchronous, it can increase anxiety between the students, and we have to pose some very strict timetable, which means it brings limited flexibility to the students. Okay, but now knowing about these pros and cons, what should we go for, synchronous or asynchronous? It's up to each one of us, each one of the teachers, each one of the people involved in these activities, academic activities that involve assessment. Of course, it depends on the activity in itself, on the students, on many circumstances, but I would say that a blend of these approaches is probably a good option, balancing synchronous and asynchronous assessment so that we can benefit from both in terms of flexibility, fairness, engagement, academic assuring academic credibility in this. We have some solutions or some approaches that we'd like to share with you, combining real-time and self-paced assessments, using synchronous methods for those activities that require interactivity to the lengths, to the bigger lengths, and the synchronous ones for the activities that require deep reflection and research. As an example, we might have live quizzes with the students that address a certain subject and then give them a case study on the same subject to work on their own. We can use synchronous assessment for active engagement, oral exams, presentations that are made via video calls, but in real time, live debates with the students. This is being very much promoted by the European Commission through the Erasmus program. Quick quizzes for formative assessment or even for summative assessment. Well, I'm not going into much detail because I'm afraid my time is running. Using synchronous assessments to promote this flexibility, essays, discussion forums, peer reviews of the work that the students are doing, recorded presentations, project-based assessments, blending both in the same assessment. We have here two examples. For instance, in one example, in the first step, to ask students to submit an analysis of a case study. So this is something that they do asynchronously, and then come up with a question and answer session where they explain what they have done. And we have here a list of other possibilities that I'm sure you will then be able to follow if you want to go and follow our PowerPoint that we'll be glad to give to you. Okay, but to conclude, all of these brings challenges for education, for educators, for teachers, and for the students. First of all, to assure academic integrity, we want to assess the competencies that our students have acquired, the knowledge they have acquired, not something else. The student isolation that this online very deep focus exclusively on online teaching might bring, and the technological issues that are for sure this digital divide can be a really serious problem. I remember in 2021 when we were locked down in COVID, we were teaching online, and I had two students that had to give up their degree studies because they could not attend. They were living in the interior in a zone with very poor internet connection, and they could not attend the classes. They were always going in and out. They could not listen. They could not intervene. So these two students, unfortunately, had to give up their studies because we were in this setting for almost 2 years, and it was really, very problematic to see that this digital divide has this impact in our young students. Okay, so to conclude, we believe there are many tools already, many opportunities, many strategies to do this online assessment merged with in these two modes, synchronous and asynchronous, and we are working our work on our research on this direction more now on collaborative work, make sure that we can use also these tools for the fair evaluation of students working in teams, working in groups, and finding ways also on how we can elevate this online assessment to promote the development of critical thinking and this type of higher order soft skills in our students. Okay, that's it from me. Thank you very much. You have the contacts of the team who have worked on this. Yeah, and I'm open for any question you might have. Thank you.
And no question from my side. It's a very good PPT you have presented. Thank you very much. Nice presentation indeed.
Ricky sir, do you have any questions for him?
No, I don't have any questions. Thank you.
Thank you.
Okay, thank you sir for your presentation.
Thank you.
Now next up, I would like to call upon Ainhoa Osa Sanchez to present her study on optimization of predictive models in breast cancer, applications and advances in feature selection. Ma'am, are you present here?
Yes, I hear.
Yes, ma'am, please begin with the presentation.
Hello, this is the presentation of optimization of predictive models in breast cancer, application and advances in feature selection. Our agenda today is a brief introduction, next our research objective, and the methodology we use, and analysis of the results, conclusions, and finally the study limitations and future work. Breast cancer is the most commonly diagnosed cancer worldwide, with 2 million of new cases in 2020, for example. While it was once more prevalent in developed countries, today over half of diagnosis and 2/3 of death occurs in less developed regions. In this context, radiomics has emerged as a powerful tool for improving breast cancer diagnosis and treatment. By extracting quantitative data from medical images such as mammogram, MRI, and CT scans, radiomics leverages machine learning to analyze patterns beyond human perception. These features range from basic pixel intensity histograms to complex texture metrics like gray level co-occurrence matrix and gray level run length matrix. Radiomics has been successfully applied to tumor classification, treatment response prediction, and recurring risk assessment. A crucial aspect of radiomics and breast cancer research in general is feature selection. This process identifies the most relevant features from large datasets, improving model performance, reducing dimensionality, and uncovering potential biomarkers for diagnosis and treatment. Several feature selection techniques also have been applied successfully in breast cancer prediction, including sequential forward selection, recursive feature elimination, and correlation-based methods. The goal of this project is to optimize the performance and interpretability of predictive models for breast cancer recurrence by integrating clinical, radiomic, and temporal data. To achieve this, we apply advanced feature selection techniques and machine learning algorithms. We use models such as random forest, XGBoost, and lasso regression to identify the most relevant predictors of recurrence. For our dataset, we use a multimodal approach that integrates clinical, radiomic, and temporal data. Our dataset includes data from 100 different patients with variables such as tumor size, hormone receptor status, and texture feature extracted from medical images like GLI-CM and GLI-RLM. Additionally, we incorporate temporal information such as date of diagnosis, surgery, and recurrence. By combining this data, we aim to improve the accuracy and interpretability of our prediction models. To select the most relevant features, we apply several selection techniques as a random forest to identify key variables like tumor size and age. Also, we use lasso regressions, which shrinks less important feature coefficient to zero, simplifying the models. Also, mutual information to capture both linear and nonlinear relationships that are important. Also, recursive feature elimination to interactively remove the least important feature. And finally, we implement XGBoost and LightGBM gradient boosting techniques that are effective for handling complex and large datasets. Before applying that, we applied a preprocessing pipeline to ensure data quality and standardization. First, we apply handling missing data. For numerical features, we input missing values using the mean. And for categorical features, we fill it missing values with the most frequent category. Second, we apply scaling and encoding. For numerical variables, we scale it using a standard scaler to improve model stability. And for categorical variables, we transform into numerical values using label encoding. And third, for temporal feature transformation, data features were converted into the number of days from the diagnosis, capturing important temporal relationship. And final, for the feature share, after preprocessing, we combine the transform numerical, categorical, and date-derived features into a single dataset for use in machine learning models. Also in methodology, I explained a structured approach that we employ to consolidate the ranking contributions across dataset. To obtain a comprehensive analysis of feature importance across dataset, a systematic approach was implemented. The first step was exporting rankings. Feature importance rankings for the machine learning models were exported to Excel file. Then a dynamic table was created to normalize and aggregate these rankings. Especially each feature ranking was ordered from 1 to the total number of features within each model. After that, these rankings were summed across all models to calculate a cumulative score for each feature, reflecting its overall importance. Also, to provide a proportional measure, the cumulative score for each feature was divided by the total sum of all scores across features. This yielded a normalized importance value, facilitating the comparison of features' relative importance within across datasets. Finally, features were then ranked based on their normalized importance values, with lower scores indicating the greater importance. For the results, we first focus on the radiomic variables derived from medical imaging data. Feature selection techniques revealed the most significant radiomic features that contribute to predicting breast cancer recurrence. In this case, intensity histogram median emerged as the most important feature across all methods, ranking consistently high in each technique. Other important features included were GLCN difference entropy, intensity histogram, and agent TDM complexity, all which showed a strong association with recurrence. Moving to the clinical variables, we evaluate their predictive power using 3 machine learnings, random forest, XGBoost, and LibGen. Some key clinical features stood out. Time to progressions ranked the highest across all of models, underscoring in a strong role in recurrence predictions. Recurrence time and follow-up time also showed consistent importance across models. And also variables such post-surgery lymph node status and last CAA measurement had a moderate importance, but were still noteworthy depending on the model. Finally, for the complete dataset analysis, progression time maintained in top position, reaffirming its central role in predicting recurrence. Other important variables such follow-up time, recurrence time, and survival time showed strong predictive values across those models. While some radiomic features like GLCM, cluster site, and GLRM, short-run low-grade level emphasis were less significant, they still contribute meaningfully to the model. Let's begin with the radiomic insights for the discussion. Radiomic features such as intensity histogram median and GLCN difference entropy consistently ranking among the top predictors of breast cancer recurrence across various feature selection methods. These features derived from medical imaging, providing available insight into tumor characteristics that are not always apparent in traditional clinical evaluation. By incorporating this radiomic feature into predictive model, we gain a more nuanced understanding of tumor behavior. This is in turn can support personalized treatment strategies. Moving on to clinical variables, we found that factors like tumor size, hormone receptor status, and lymph node involvement also emerge as a significant predictors of recurrence. This finding align with established clinical knowledge, reinforcing the importance of incorporating traditional clinical factors alongside advanced imaging data. Notably, the consistency of these clinical variables across various machine learning models highlights their robustness and relevance in predicting outcomes. Next, we explore the role of temporal variables. These include the interval between diagnosis and disease progression, and they added a dynamic aspect to our predictive models. By capturing the temporal relationship within quick clinical events, we can gain a deeper understanding of how disease progress and how recurrence patterns evolve over time. These variables therefore contribute to more comprehensive view of breast cancer recurrence. In terms of feature selection and models performance, we use several techniques, including, as I said, random forest, lasso regression, and recursive feature elimination to assess feature importance. Each method provides a variable insight, and their combined application ensure a balanced and thorough evaluation. By employing multiple feature selection techniques, we mitigate the risk of overfitting and improve the generalizability of our models. To conclude, our study demonstrates that integrating radionomic, clinical, and temporal data provides a powerful framework for predicting breast cancer recurrence. By focusing on the most influential features, clinicians can better assess patient risk and tailor treatment plans accordingly. This personalized approach not only assigns patient outcomes, but also helps optimize resource allocation within clinical settings. By improving our predictive model, we can advance personalized medicine in oncology. Finally, while our study presents significant findings, we must also acknowledge certain limitations. The dataset is limited to HER2-positive breast cancer patients, which may restrict the generalizability of our results to other subtypes. Additionally, potential imbalance in the recurrence outcome distribution could introduce biases, making further validation on external datasets necessary. Future research should aim to integrate multiomics data, such as genomics and transcriptomic profiles, to enhance the predictive power of our models. And also, we need to expand the dataset to include larger and more diverse cohorts will also improve the robustness and applicability of our findings. Thank you, and then I open for any questions.
Ma'am, can you please come to your missing values and how you have taken care of the missing values in your research?
Yes. Yes, I input for numerical data. I input the mean of the total of the variables, and in case of categorical, I put the most frequent category.
But ma'am, when you have used numerical mean imputation, then the distribution of the data generally will be changed. Then how?
In our case, the data distribution not change because in our case, the numerical data, it was only 3 or 4 missing. It's not much.
Hope you have understood my query. I am asking you or requesting you, when you are using mean imputation numerical data by using handling your missing data, that time the distribution of your mean imputation values will be higher. And due to this, the machine will not respond to a accurate one. How you have handled this? That is the query. Otherwise, no issue. You please check once how to handle this missing data by using rather than mean value. Otherwise, it's a very good presentation indeed. For journal publications, you must check these points as well so that the methodology and data preprocessing part will be the best one. Thank you.
Thank you. I didn't know that.
Ricky sir, do you have any questions for her?
No, I'm good. Thank you.
Okay, thank you, Ainhoa, for your presentation. Now, before we reach the closing remarks, I would like to give one last call to Debjani and Pei Ihao if they're present, or if anyone of the co-authors of the paper is present. Can you please show up and present your paper?
Ma'am, might be possible they are having some network issue. So as
Okay.
Springer needs the paper must have to be presented. So please ask them to share the video PPT. And if within the final day, if they can't send the video PPT within time, then you may take your decision regardingly. Thank you.
Yes, sir. Sure, sir. I will take that into consideration. Thank you, sir. Okay, so now we'll be reaching the closing ceremony. I sincerely thank our co-authors for their presentations and for the session chairs to be available today. And I sincerely thank for the excellent presentations of all the participants for being a part of this international conference. I hope this session was informative enough. And we, on behalf of whole team, thank you for the support during this 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already forwarded to Sprinter. The publication will be live within 6 months, and kindly cooperate with the team of ICICT 25. I also thank our session chair, Dr. Ricky Sun and Dr. Tanupriya Chaudhary, for their presence in this session. And I would request Mr. Ricky Sun to give a closing remark.
Sure. Well, today we are very happy to be here to listen to 4 presentations. Unfortunately, there are 2 not present, but hopefully they can make it, using their video PPTs. But this is a wonderful experience. I'm happy to be here and hope you all enjoyed the whole process. So I think, that like this is a great experience. I came from an industrial background. I'm not exactly academic, but I understand. But I think most of the breakthroughs we're seeing today, really initially, most of those came from academic research. So never underestimate the part of that. So let's all work together, in building a better tomorrow. I guess that's all, the kind of information I want to extend to all the presenters here today.
Thank you so much, sir. And I would also like to thank Dr. Tanupriya Chaudhary for chairing this session. Sir, if you have any closing remarks for the presentees, please.
And thank you very much. Thank you very much, GR Foundations and the other presenters for their nice presentation. And I have shared my email ID. Those anyone are requested to share their ideas or for any collaboration, they are welcome. And if possible, they can connect us with LinkedIn as well. Thank you and all the best.
Thank you, sir. Now,
Thank
as we
you.
reach the end of the session, I would request everyone to switch on their camera for a quick snapshot of the virtual conference. I repeat, everyone please turn on their cameras for a quick moment. Okay,
Thank you,
thank you,
everyone.
everyone. Have a good day ahead. Thank you.
Welcome. Thank you.
Thank you, sir.